Hello. Hi, Isabel. Welcome back. Sorry for that confusion earlier. Welcome, Sharifa, and welcome, Griselda as well to this first class in the A Star series. Welcome, Nikki, as well. Isabel, I'm just going to pop your mic off just because I'm making a little bit of reverb, but you can pop it back on if you have a question at any point. But I know a couple of you in the previous series, a couple of you are new. So just to let you know how these classes work, welcome Izzy as well. So basically, this is going to be a 16 class series. So obviously today we've got a class on a Wednesday. We've got a class tomorrow at 7:15 as well. For the majority of the series, the classes will be on Thursday and Friday at 7:15. There is 1 week in the middle. It will be on a schedule where I've had to move them to Monday and Tuesday. I think that's in around 3 weeks' time. It will be, I'll confirm it the week before as well. And how the course will work, it's an 8 week course of 16 classes or lectures. And so we'll have a first 12 where you're going to go through different topics. And as I go through the topics, I will share the notes on the screen. I will annotate as I go through as well. I think you can find access to all the notes from the course as well on the A Star site, at least the non annotated version. And yeah, just to say as well, all of these lectures, all of these classes are recorded. I will set up a new playlist shortly where the classes from this series will be put on and get uploaded to, and I'll be added to the A Star site as well. You can still on the site as well. You can get access to previous running of a series if you want to refresh with that, or maybe go ahead in the course if you've got an exam coming up or anything like that. You will be able to access it there. And how it works in the form of a lecture. However, if anyone has a question at any point, please don't hesitate to ask. You can either put your questions within messages on Zoom. Alternatively, it's no problem to put your microphone on to ask something as well. Not a problem at all. But the first three classes for today and then the next two, we are going to focus on algebra. So we're going to look at many of the various areas of algebra which can come up in the A Star exam. And so algebra, sort of in, if we're going to generally put what algebra is when letters in maths are put in the place of numbers. And so it's important when it comes to algebra to understand some of the terminology. And we're going to start by looking at terms and in particular like terms here. But a term within algebra is basically either a number. So any number, although you just get them in normal maths, is just a term. It can be, so just like 6 would be a term. It could be a letter on its own. And if you've got a letter on its own, it just means it's one of that number. Or it could be a combination of numbers and letters. It could even have powers as well. So say you could have sort of 3x squared y. And whenever you see a letter in maths, so if you see a question with x mentioned more than once, x will always represent the same unknown number. So the same letter will always represent the same unknown number. Now, in terms of terms, when you've got terms together joined by either an addition, an add, or a subtraction sign, this is known as an expression. So down here, you've got sort of 2x plus 3y. This is known as an expression here. And whenever you've got sort of an expression with an equals with something on the other side, and this is something which will be solvable. It's known as an equation. So, for example, here we've got 2x or two lots of x plus 1 equals none. We'll look at equations and how to solve them next class, but in basic terms, this will mean that x equals 4 because 2 lots of 4 is x, plus 2 lots of 4 is 8, plus 1 equals 9. So for this equation to balance, x would have to equal 4. So as I say, the letters in maths, the letters in algebra, they always are in the place of a number, but in the case of an expression, you can't solve what that number is, but maybe you can put a number within to solve something on certain questions. But when it's an equation, you can rearrange the equation in order to find out what the missing number is, what number is represented by the letter. Now, it's important to realize in terms of algebra, but whenever you have a number and a letter together, it means like the number multiplied by the letter. So when we've got 3x, it means 3 lots of x, or equally 3 times x. We just wouldn't write the times there. Equally, if you've just got a letter on its own, it means there's one of them. So if you see x, it just means 1x, or y, you've got 1y. It's just we wouldn't write the 1 there. But if you see on its own, that means there's one of them. Now, equally, I should just to mention with the first one here, you could have, if you have a combination of letters again, say we've got 4x, y, it means in effect 4 times an unknown number represented by x times an unknown number represented by y. Or exactly. So when we've got the x here, if you've got x with a power, that means it's multiplied by. So if you've got x squared, well, if you square a number, 6 squared means 6 times 6. So x squared just means x times x. Just like if you saw, let's say you saw x cubed, it would mean x times x times x. Just if you see a number cubed, it's multiplied by itself three times. Now, finally, you often see it written as a fraction, something over in algebra. We often use fractions and it's working in a way of division. So if you've got x over 3, it means a number represented by x divided by 3. So say if you saw x over 3 equals 2 as an equation, it would mean x would equal 6 because 6 divided by 3 equals 2. All right. Okay, so we'll move on from that. And the first thing we are going to look at today is collecting like terms. So in algebra, something is a like term if it's got exactly the same combination of letters. So, for example, numbers are like terms because I haven't got any letters, so we can add or subtract numbers, of course. But equally, if you've got here in this example, you've got 3x plus 2x. Well, these we can put together. It's like we've got 3 lots of x when we've got 2 more lots of x. So you've got 5 lots of x in total. Below we've got x, which of course means 1x. We just don't write the 1. Then you've got 9x. You've got 10x in total. However, if you've got a situation like x plus 3y, you cannot simplify this. You cannot put them together because they're not like terms, and we don't know what x and y equal either. So it would be, it's not possible to combine them. This can't be simplified. This can't be collected in any way. Now, you could get here in terms of more than one thing on the same. So if you've got like 5x minus 3x plus 11x, well, it's just like doing the numbers. 5 take 3 plus the 11. And they're all like terms because they're all with x. So you'd have 13x in total. But you could get a question, it's very common, you get a question with more than one type of term and be asked to collect them. So say we've got 4x plus 2y plus 3x. Well, in this case, 3x and 4x are like terms, so we can put them together. 4 plus 3 equals to 7. And then we've got here, we've just got plus 2y, which means we can just, it's the same as just having positive 2y. Positive and plus mean the same thing, just as negative and minus doing the same thing. So we can simplify it to 7x plus 2y, but we can't simplify it any further because we can't put the x's and y's together. Okay, well, we can have a look at a few more examples here. So we've got, first of all, the questions, it would normally say here for a title. Obviously, we're lacking a title here, but we normally say either simplify the following. And when you see simplify to do with algebra, it means it's not a question you can necessarily solve. You can just write it an easier way. Or it could say collect the like terms. In this first example, we've got 3x plus 4y minus x plus 2y. And normally what I'm going to do is I'm going to circle out, I'm going to take out the like terms. What's important is you use the sign before something. So if it's take x, it's like minus x. So we've got 3x minus x. Well, remember x, it means 1x. We just don't normally write the x. So 3 take 1 just gives us 2x or positive 2x. Now for our other terms, we've just got pluses. We've got plus 4y and plus 2y. So we can just do 4y plus 2y, and that's going to give us 6y to give us an answer here of 2x plus 6y. Right. Well, we've got our second example here where we've got x's, we've got y's, and we've got xy. So it'd be easy to think that these are the same, but you can put these together, but you can't because for to be a like term, you have to have exactly the same combination of letters, and that would apply to powers too. Incidentally, if it was in the question as well. So in this question here, we've got 4xy, but the only like term to it we've got is, well, plus 3x doesn't have a y, so it's not exactly the same. Minus 2y doesn't have a x, it's not the same, but plus 6xy is exactly the same. So we can put these two together. Well, 4xy plus 6xy equals 10xy. And it's important to understand as well that when you are dealing with collecting like terms, when you are simplifying in maths, the powers never change. It's like you've got 4 lots of xy, then you add 6 more. You can think of it the same way like anything in life. If you have 4 apples and you had 6 more apples, you're going to have 10 apples, and so nothing's going to change with what you're collecting. The same here in maths. You got 4xy, yeah, add 6xy, you got 10xy in total. Well, we could do the same with our x's now. So you've got plus 3x, and there's nothing else here, so that's on its own. We can wait for later. But our final two, well, we've got minus 2y. Again, we need to use our sign before, and we've got minus y. So we've got minus 2y, which is our starting point. Then you take y away. And if you take away, you're going sort of further down the number line, further away from 0. So it's going to get some minus 3y. Minus 2y minus y. It's like the mirror of doing 2 plus 1 minus 2. Take 1. So at least it's with minus 3y. Well, now we've done that, we can write out our final answer. We need to make sure we remember to include 3x. It doesn't matter, by the way, what order you put them in, as long as you put the correct positives and negatives. You could equally write minus 3y plus 10xy plus 3x. It would mean the same thing. Now, our last example here has powers. So here we got 3x squared minus 2xy minus 2x squared y plus 4xy squared minus x squared y squared. Well, when you've got power, remember it means something is multiplied by itself. So effectively, just like 3x means 3 times x. Well, x squared means x times x. So effectively, you've got 3xx. And then for 2x squared y, a power only applies to the letter it's above. So you'd have 2xxy, you'd have 4xyy, and you'd have minus xx y, y. Well, when we write it out like this, we can see that none of these have exactly the same combination of letters, so we can't put them together. You have to have exactly the same powers too for this to count. So we can't simplify, as none of these are like terms. Okay. Now, often with like terms, it's a topic that often comes up early in the exam. You might get a couple of ones with this. That's something to be familiar with. It may also be the end of another algebra question. So we're going to be looking at brackets soon, and it always you collect like terms, you simplify in double brackets questions, as we will see. All right, but we're going to move on from that now, and we are going to move to expanding brackets. And so expanding brackets is basically you will see this word again. It's algebraic language. You'll be asked to expand brackets, and whenever you need to expand brackets, it means you need to multiply them out. So within the foundation maths exam, you are going to come across two types of brackets you need to multiply out: single brackets and double brackets. Well, when it comes to single brackets, in order to expand them, you need to multiply all of the terms within a bracket by the term on an outside. So we've got an example here. We've got 3x plus 2. And so the maths you do, I'd always work from left to right. It's a logical way to work. But we would do here, we're going to do 3 times x. And that's what's got us to the 3x here. It's like 3 lots of x. And then 3 times 2, which is what's got us to 6. You end up with 3x plus 6. Sorry. All right, and so we got a second example here. We got 5 2x minus 1. We're going to start exactly the same way, right? Left to right. So we do the 5 times the 2x. Well, that's going to give us 10x. And then we do the 5 times minus 1. So again, be careful, just like on collecting like terms, to use the sign in front of it. Take 1, you do 5 times negative 1. Well, in maths, a negative times a positive is always going to be a negative. So if you've got the 2 signs different, it's always going to be a negative. Then you can just do 5 times to 5, so it gives us negative 5. So we end up with 10x minus 5. Well, the next example here, we got x plus 1. And remember, it means like 1x at both points. But first of all, here we've got x times x. And then we've got 1 times x. So x times x. Well, remember, if you times anything by itself, you are squaring it. So x times x equals x squared. And then as well, we've got next, we've got x times 1. Well, that's just going to still give us 1x, and we're still going to just write as x because we don't put the 1 in front. So it leaves us with x squared plus x. Okay, the next example here, we got 4x, 2x plus 1. So again, we work our way down. And for me, the easiest way to deal with these when you're dealing with slightly more complicated terms is to deal with one stage at a time. So first of all, I'm going to see if there's any negatives about effects, where there's not in this case. Then I can do 4 times 2, which gives me the 8. Then I can do x times x, which gives me x squared. So in effect, I'm working my way down, multiplying the like terms together. And then on the other side, we've got 4x times 1. Well, again, anything multiplied by 1 is itself, so it's just going to be positive 4x. One more example here, we've got 7x plus 3y. Well, again, we do with one stage at a time. We do 7 times x. 7 lots of x gives us 7x. And then 7 times 3y. So no different, even though it's a different letter with inside. We do 7 times 3, which gives us 21. Then the y is just still on its own, so 21y. Okay. Okay, so we're going to look at another couple of examples of this here. So we got, first of all, we got 2a plus d. And again, it's not saying the words here. What it would say in the exam, it would say expand the following, or something along those lines. So it's called expand in brackets when we multiply out. So first example, we got 2a plus d. So again, nothing's changed here. We can deal with one stage at a time. We can do 2 times a, or 2 lots of a, which is what 2a means. It just means 2 times a. B, we've got 2 times d. Okay, that's just going to give us 2d. And so we just end up with 2a plus 2d. Okay, now we're going to move on to our second example here. So we've got 5x, 3x minus 2y. Well, here, again, we can work our way down. So we can do, first of all, we're going to do 5x times 3x. And again, as I say, I'm just going to work my way sort of through the sum, deal with the numbers first. So 5 times 3 gives me 15. Then deal with x times x, and so anything times itself is squared, so 15x squared. Well, then for the other part, we have got here, we need to keep an eye on the minus sign, remember to include it. We've got 5x multiplied by minus 2y. So the first thing to think about here is it's a negative times a positive, and a negative times a positive, as I say, is always a negative. So now we've done that, we can do 5 times 2, which can just give us 10. And then we've just got our x and a y. We haven't got anything to multiply them by, so it's like x times 1, y times 1, so it just ends up with 10x, y. And just to say, whenever you're dealing with letters within algebra, you always want to make sure that you put the letters in alphabetical order. And this is the normal process for anything like this. You always put in alphabetical order. So this will end up, we've got 15x squared minus 10xy, and then it's just remembering to write out at the end, 15x squared minus 10xy. All right, well, we got the next example below, and you could be forgiven for accidentally thinking, because you've got 2 brackets, is a double bracket question. But because we have got a term inside the bracket, in between the brackets, that means it's effectively 2 single brackets. So I think the best way to deal with this question is to just pop a line here and then deal with both single brackets separately. So over here we can do 4 times x equals 4x. Then 4 times 3 equals 12. So we've got 4x plus 12. Then on the other side it's positive 7, so it's 7. 7 times 4 equals 28. And then we've got 7 times minus 2x. So remember, we need to include the minus. Well, a negative times a positive is a negative. 2 sevens are 14, and then an x on the end. So we've got plus 28 minus 14x. Now, I should say, on a question like this is actually from a past exam. These questions, I think, in all of these ones have been, but it would say expand and simplify. And the reason for that is because now we have expanded out these brackets, we can collect the like terms together just like we did before. Now we've got 4x minus 14x. Remember, now we're dealing with addition and subtraction, so our powers don't change. So just 4 take 14. So actually, if you take a bigger number from a smaller, you can do the smaller from the bigger. So 14 take 4 equals 10, but then it will just be a negative. So it's negative 10x. And then separately, we have got plus 12 and plus 28. So we've got 12 plus 28, and that's going to give us 40. And that leaves us with a final answer of minus 10x plus 40. As I say, you could write it the other way around. You could write 40 take 10x. Either of the two would be perfectly acceptable. Okay, we're going to move on from that. So the next thing we're going to look at here, we've got double brackets. So those with single brackets there, and again, when you've got double brackets, you need to expand. But a double bracket question, it will come later in the exam. It's generally seen as at least a grade 4, probably a grade 5 topic, to be honest. They do come at the end. But as long as you can learn the process, then relatively straightforward compared to other later exam algebra questions. And the easiest way to expand double brackets is through a method we call FOIL. And FOIL is like abbreviation for the letters, for the sums you need to do. Because in order to expand double brackets, you need to multiply all of the terms within the first bracket by all of the terms within the second bracket. And equally, if you do this, an expanding double brackets question will always say expand and simplify. And the way you will simplify is by putting the outside and the inside together. That is how you are going to simplify. So we got an example of a question here. And as I say, the question itself, it would undoubtedly say expand and simplify the following. So we've got the brackets at x plus 3, x plus 2. So you see the letters we've written out here. Well, the F at the start of FOIL, it stands for first. And what it means is you multiply the first term in the first bracket, so the x, by the first term in the second bracket, so the other x. So we've done the x times x, which will give us the x squared. Okay, well, once we have done that, the next letter we are going to get to is the O. And so in order to do that, what the O stands for is the outside. The outside. And what that means, think of it like the outside lanes on a motorway. It's like the first thing in the first bracket by the last in the last. The two parts on the very outside. So in this case, it would just be the x times 2, which will give us 2x. Where the O stands for outside, you don't get any prize for guessing. The I stands for inside. And it's going to be the 2 in the middle. In this case, we've got 3 and x, which gives us the 3x. And then finally, you've got the L. Well, if the F stands for first, you can probably guess, but the L is going to stand for last. So we can do that. The last two, we got 3 times 2, and it gives us 6. You can see down here, once this is all we've done, we've got x squared plus 2x plus 3x plus 6. Well, double brackets questions are always going to say expand and simplify. And if you use FOIL, it's always going to be the same part you simplify. You always simplify by putting the outside and the inside together. So in this case, we've got plus 2x and plus 3x. So we can simplify them. 2 plus 3 gives us 5. Remember, but when we are simplifying, we are now dealing with addition. So once you are dealing with addition at this stage, the powers are not going to change. With additional subtraction, the powers do not change at all. So we can do that now. 2x plus the 3x gives us 5x, gives us a final answer for x squared plus 5x plus 6. And actually, what you get when you expand double brackets, this is what's known as a quadratic equation. A quadratic's an equation with the x squared in this form. We're going to come across them again. Quadratic equations are something, but we'll come back when we come to factorizing brackets and solving quadratics later in the course in the next couple of classes. Okay, well, we've got a couple of examples here. So again, we'll write out a word and it would say expand and simplify. And again, we want to use the same method as before. We want to use FOIL. So we can start again with F for first, which means x times x. Anything times by itself is squared. It just gives us x squared. Well, next off, we have got our O, which is for outside. So we can do x times 6, just gives us 6 lots of x, or 6x. Next, we can do I, or the inside. Now we've got 4 times x. We've got positives in both brackets, which makes this nice and simple. That gives us 4x. And then finally, we have got our L, you can T and L. We got the last in both. So we got 4 times 6, which gives us 24. Okay, so now we've expanded out the brackets, but we've still got to simplify. And because we have followed FOIL, we've got our outside and inside together. We've got 6x and 4x, where 6 plus 4 gives us 10. So it means we've got 10 lots of x in total. So it gives us our final answer of x squared plus 10x plus 24. Okay, moving on from that, we've got one more example below. So we've got 3x plus 2, 2x minus 7. So we've got minus now. We need to be careful with that. Got a couple of numbers at the start, but our process is still the same to expand and simplify. Going to start with our first. So we've got 3x times 2x. 3 times 2 equals 6. X times x equals x squared. Next, we got our outside. We need to be careful because it's minus 7. So we got 3x times negative 7. Well, negative times a positive is a negative. 3 times 7 equals 21. And remember to put our x. So we can do that. Well, we've done the outside, but now we want to do the inside. 2 times in the middle. So we have got 2 times 2x. Well, 2 times 2 equals 4. Add the x in. And then finally, we can go to our last term here. Well, the first in the first times the last in the last. Remember in our negative below, so we've got 3x times, so I'm just going to make that a little bit neater because it looks terrible. We've got 3x times negative 7. 7 for 3. Well, remember it's a negative times a positive gives us a negative. 7 3s are 21, and then an x on the end. And so now, again, we've done it in order. So we need to collect our like terms, which are going to be our outside and inside. So this time we've got minus 21 plus 4, or 4 take 21. It means the same thing. Remember, the easiest way to do that, we can do 21 take 4, which gives us 17. But just remember to put a minus sign in. So we have negative 17x. And now we've done that, we can just write this out. So we've got 6x squared minus 17x minus. No, sorry, I've just made a slip there at the end. My brain obviously went. I realise I've done the wrong sum for last. Apologies for this. Not sure if any of you have written it in the chat yet because I'm in the other window. But I should have been doing here, of course. I should not have been doing um, um, the outside again. I should have been doing 2 times negative 7. So negative times a positive is a negative, and 2 sevens are 14, which just means we got negative 14 um, on the end of this. All right. And so just with that last one, obviously, I caught the slip down. Part of the reason I caught that slip myself is because I've set it out in this way. Because I've done it in FOIL, I know that the elder number at the end is not going to be a like term. So as soon as I saw that when I was coming back through, straight away it raises the alarm bells that you made a slip. So always good to always set things out properly, do it in the right way, and then it can really help catch any sort of silly errors like I've done there. Okay, well, to finish with today, we're just going to talk briefly about one further topic, and that is the rules of indices. And actually, we've been coming across these rules as we've been multiplying our powers, but there are rules you can learn to this, which can really help you out. Understanding the rules of multiplying and dividing in terms of indices. So the first rule we got here is when you multiply like terms, you can add the powers together. So just like, by the way, when we've done x times x equals x squared. Well, just as we don't write 1x, we don't write x to the power of 1, but effectively these are both to the power of 1. The 1 plus the 1 gives us the 2. And down here we've got x cubed, so x to the power of 3, times x squared, so x to the power of 2. And so we can just add those powers together, the 3 and 2, to get 5. And the reason that works, remember x cubed, well, it just means x times x times x. And then we've got multiply in the middle, and then we've got x times x. So if you think about it, we've got x times x times x times x times x, or x to the 5. But of course, the main thing you just need to remember, add those powers together. Now, when it comes to division, you need to subtract the powers. It's the opposite of multiplication. This time we need to subtract. So if you've got x6 divided by x4, you just do the 6 minus 4. So it's going to give you x squared. And as mentioned before, you're often going to see this in the form of a fraction. So it could be like x3 over x. Remember, x just means x to the 1. So it equal x squared. Again, that means the same as division in this case. All right. Well, one difference we can get here is when you've got a brackets. So when you've got brackets with one power inside the bracket and one outside, you multiply those powers together. So if you've got x to the power of 4 squared, then you would do 4 times 2. So it would give you x to the power of 8. And that's because there's something squared, it's multiplied by itself. So it's like you've got x times x times x times x. But now we need to times it by itself. So we do that, multiply by x times x times x times x. It gets to a lot of x's. And then all you'd end up with x to the 8. So we can just multiply those powers together. Now, a couple of small rules that I'm going to mention before we go into the final example, which aren't here. If you see anything in maths, so you've got x to the power of 0, anything to the power of 0 equals 1. It doesn't matter what it is. If you had 78 to the power of 0, it would equal 1. Equally, you could get a question. It's not really with algebra, but it is with powers. it would be possible to get something in the exam such as 27 to the power of 2/3. And if you see this, what it means is more likely you get this in a calculator, to be honest, it's a bit fiddly, is that you'd almost do like you do the root to the bottom of it. So you do a cube root. So we need to work out what times what equals 27. Well, 3 times 3 equals 9 times 3 equals 27 equals 3. And then you'd power to the numerator. So then we'd square it and it would give us 9 in this case. By the way, by the same token, it means, say, for example, if you get 9 to the power of half, it just means the same as the square root of 9. So it would just be 3. They mean the same thing because we do the root to the bottom power. So just mentioning these in passing as they could possibly come up on your exam and they link most closely to this topic. Just one other thing I'm going to mention. If you see something that say 3 to the minus 2, well, if something is a minus, it creates an inverse. And what that means in effect is it becomes the denominator, the bottom of a fraction with the numerator as 1. So it'd be like 1 over 3 squared or 1/9. So if you see to the minus, it becomes the bottom of a fraction with 1 as a top, and then you would work out the squared or whatever it is as normal. All right, so we're just going to look at a few of these to finish. Again, these questions here, they would say simplify because we are dealing with expressions, not with equations, because we can't solve these. We're just writing them in different ways. So if you have 2m times 3, well, you can multiply the numbers together. So 2 3s are 6. The m would just stay the same. If you've got n3 times n5, well, in this case, we've got two powers. We can add them together. It just 3 plus 5 gives us 8. So it'd just be n to the power of 8. And if you've got 1 inside brackets and 1 out, you could have x cubed. And it's for 3 times 5. That's 5 lots of x cubed. And that's going to give us x to the power of 15. And one more example here. We've got C3, so we've got some compound terms. So we've got C3D4 over C2D. So deal with both parts separate. Remember in its division, well, C to the 3 take 2. It's just going to equal C to the 1 equals C. D to the 4 take, and remember if there's no powers, take 1 equals D3. So we're just going to end up with C D3. I'm just going to give one more example below because you might see, for example, you could see a question where it was like 25 x 4 y 6 over 5 x minus 2 y 3. Well, in this case, the numbers we just deal with as numbers. So we just do 25 divided by 5, which will give us 5. Then we would need to do x to the 4 minus 2. Well, when you've got the two minuses together in the middle, as we have here, they are going to cancel each other out. So the two minuses together makes a plus, so it becomes 4 plus 2, and so it equals x to the 6. And then we've got the y6, and it's just 6 take 3, and that's just going to give us y3. So our final answer here would be 5 x6 y3. So important to understand that when you are dealing with indices in the exam, if you've got numbers in both parts, you just deal with the numbers separately as you do with numbers. So equally, let's say you've got, I know I'm going to fit it, you say up here, I'm going to squeeze in another question. So let's say we've got 4x squared y3 times 7x 5y minus 6. Well, we just deal with everything separately. We do 4 times 7, which will give us 28. We do x squared times x5. 2 plus 5 equals 7. And then we do y, 3 plus minus 6. Well, plus minus 6 is the same as 3 take 6. And so that's going to give us minus 3. So you'd end up with 28, x7, y minus 3. Okay. Well, unless anyone's got any question coming through, that takes us to the end of today's first class. So hopefully that's given a bit of a sort of an understanding, background, some of the areas of algebra. Tomorrow we are going to be focusing on solving equations. So we're going to look at a lot of the problems when it comes to solving equations, different stages. The earlier versions, like the versions we saw at the start today, can be quite simplistic, but they can get a little bit more complicated as we go through them. But yeah, thank you so much to the 5 of you for your concentration tonight. It's really appreciated. As said, tomorrow night we are going to be at the same time. So it'll be 7:15 tomorrow night, and then we'll go for that. Sorry, Izzy, I've just got a question from Izzy. So that very last question example. Please could you explain one more time? Yeah, no problem at all. I will do that. Sorry, I think it's because I've squeezed it a little bit of a side, perhaps haven't put as useful work in here. So in fact, I'm trying to think if I can get a good bit of space for it here. I'll just go underneath here. So we've got 4x squared y3 times 7x5 y minus x. So the first stage we've done, in effect, we've done 4 times 7. So we multiply like terms. We deal with each of the like terms separately. So first we deal with our numbers. So 4 7s are 28. Secondly, we've got our x's. So we've got x2 times x5. So remember, when you're dealing with the indice rule, when you're multiplying powers, you add them together. So we've got 2 plus 5, so it gives us x to the 7. And then finally, we have got y3. It's 3 plus minus 6. So if you're adding a negative, the signs, they cancel each other out and they make a takeaway. So it's like 3 take 6, and that's why it equals y to the minus 3. And then it's just a case of putting them all together. So 28 x7 y minus 3 at the end. So does that make sense? All right, Izzy, you're okay? All right, brilliant. Glad to hear it. So yeah, thank you so much to all of you. Hope you have a brilliant night. Hopefully see you back here tomorrow at 7:15 when we'll carry on going through algebra. Thank you very much. Bye bye.